Hello and good day. This is John Requezan, your first reporter.
And I am Ronald F. Baderna, your second reporter.
We are the representatives of the Parabola group to discuss with you a word problem, including parabola with complete solution. But before we move on to the problem, let us first go back to the meaning of a parabola.
It is a plane curve formed by the intersection of a right circular cone with a plane parallel to a generator of the cone. It is also the set of points in a plane that are equidistant from a fixed line or a fixed point in the same plane or in a parallel plane.
So here we have the word problem. Hermione disassembled a flashlight with a parabolic reflecting mirror to know its equation. She then measured the diameter, which is 8 inches, and a depth of 4 inches. The cross-section of the parabola, which is the vertex, is located at the origin, whose focus, or where the light source is placed, is at 1 unit away from the vertex. And on the given problem, we are asked to find for the following: A. The coordinates of the focus and endpoints of the parabolic flashlight using a graph. B. The directrix and its latus rectum. C. The distance of the light source from the vertex, and lastly D. The equation that represents the parabolic flashlight. First step is to identify the given. This includes the width, which is 8 inches, depth that is 4 inches, and vertex at the origin. We can easily find the focus since it is stated in the problem that the focus is 1 unit away from the vertex, which means that it is 1 inch away from it and has a coordinate of 0, 1. Easy as that. To find the endpoints of the flashlight, we just simply divide the width, which is 8 inches, into 2. Because 8 inches is the diameter and finding its radius is a way on locating the 2 points. 8 divided by 2 is 4, so the coordinates of the endpoints are -4, 4, and 4, 4. This is the graph that represents the endpoints on the parabolic flashlight.
Letter B asks for the directrix and latus rectum. Knowing that the directrix is always the opposite of the focus, we simply turn the positive 1 on our focus into a negative 1. So this will lead us to the answer of 0 and -1. For P is the formula used in finding the latus rectum. So here, we will substitute the P or focus to 1. And that will give us the answer of 4 units. So our conclusion is that the directrix is at 0 and -1, and our latus rectum is 4 units.
For the letter C, it is pretty easy to find the distance of the light source from the vertex since we already solved for the focus, which is 1 unit away from the vertex. So the answer is simply 1 inch. Conclusion for letter C, the distance of the light source from the vertex is 1 inch going upwards. And lastly, letter D, finding the equation that represents the parabolic flashlight. To find the equation of the parabola, we just simply use the standard equation and just substitute. X squared is equals to 4py, substitute p as 1 because our focus is 1 unit. X squared is equals to 4 times 1y will give us the answer of x squared is equals to 4y. Conclusion: therefore, the equation that represents the parabolic flashlight is x squared equals 4y. And there we have it. We finished finding all that are asked and were able to provide answers with complete solutions. Again, this is the Parabolic Group. Thank you for listening.